So let's start. I would like to welcome everyone who has joined today to our first virtual meetup, but actually not the first itself. It's actually the fifth one. Unfortunately, we are meeting online today. Due COVID restrictions, we decided that for safety reasons, it would be better if we would organize current one online. So today's agenda, we would have two presentations. There would be a small break between each and all the questions would be a separate session after two presentations. Anyone who have questions can write in the chat or would be able to ask in person after two presentations. So I would like to ask Augustinas to share his screen and show us his presentation.
Yeah, just before that, sorry, Augustinas, if you have any questions during the presentation, just post them in the chat so you don't forget them at the end of the sessions. Yeah. And we will read them out loud during the Q&A session. So go ahead, Augustinas.
Hello, everyone. Can you see my screen?
Yes.
Okay. Actually, it's good that it's happening online because Saturday I got positive COVID test. So I'm in isolation now, but I feel good. Okay. So my presentation is logging in Kubernetes with Loki. I currently work at Omnisend as site reliability engineer. We at Omnisend have a mission to make marketing relevant. And Omnisend is e-commerce, email and SMS marketing automation platform. We are a team of 180 people and we have more than 70,000 brands using Omnisend to grow their businesses and convert their customers. And we are always looking for people to join our team. So check out Omnisend website for more information and career page. Agenda of this presentation is here. Actually, presentation is called Logging in Kubernetes, but now that I look at this, it looks more like Loki overview, but still, it's kind of good. So first, we're gonna review current popular logging setups. Then we're gonna check out Logi features, dive deeper into its index, its components. Then we're gonna review how we implemented Loki at Omnisend and quickly review logging query language, specific language for Loki. So first, popular logging setups. I highlighted a few of them. So the first is ELK, Elasticsearch Logstash Kibana. It's supposed to be the most popular one, but works like a blueprint for everything else. It's kind of all logging setups have similar steps in high level. So it's data collection. Here you see log bytes. I forgot how the service is called. It's actually collecting logs from services, pushing them to data aggregation solution, which is Logstash in the middle. Then data aggregation and processing solution pushes process data to index store. In this example, it's Elasticsearch. And then there's analysis and visualization tool, which queries the database with logs and is able to visualize and analyze those logs. So what are the challenges of deploying this infrastructure? So first, it's index store. It's kind of expensive. If you have very small infrastructure, you still need to launch quite expensive database, configure it, and then you also need to configure data aggregation and processing really well so that logs would be indexed correctly. This data aggregation processing was a little bit improved with FluentBit. I think this setup is more popular right now, or at least more up to date, where for log collection FluentBit is used and for log aggregation processing FluentD is used. It solves some of the problems for deploying in Kubernetes and getting the logs from the cluster, but it doesn't solve this expensive database problem. Not kind of problem, but a challenge. And for Loki, infrastructure looks a little bit different. We still have these 4 high-level steps: data collection, aggregation, storage, and analysis and visualization. But instead of Kibana, we have Grafana, which everyone is familiar with and use it for monitoring. We are missing index store because Loki doesn't have that doesn't index data, so you don't need it. We have all logs compressed and stored in the cloud in a bucket, and we use Loki from tail to collect logs from Kubernetes cluster. I'm gonna dig deeper into Loki features and try to explain how Loki was designed and how is it able to live in this kind of infrastructure. So Loki features. Loki was first released in 2018, inspired by Prometheus. So if we go to Loki documentation in Grafana Labs page, this is the first sentence that they described themselves, at least a few months ago when I was preparing this. And I highlighted core concepts through which I'm going to go through. And for me, it's the best way of explaining how Loki works and why it does what it does. So the first is Loki is highly available, Loki is scalable, it's cost effective and easy to operate, and does not index logs. And one more thing, it was built for developers and operators, keeping them in mind as the users of this tool. So Loki index and architectural trade-offs in the design. So as it says, Loki does not index the contents of logs, but rather set of labels for each log stream. So how does it work? In the top, you can see a log message. Printing is not supported by a printer. This is a log, some text. We don't index it. We index this metadata from where the log comes from. So these are labels, the top component, location, and level, and they describe unique streams. Stream, you can think about it as a source of log. So this is one stream described by 3 unique labels. If the level would be different, for example, info, this would describe another stream. You can see that and the left side of these labels are indexed, but that text and the log message itself is not. If we are to write some logs to Loki, you can see some other log messages with similar labels. They're considered as coming from one stream, and all these text data is added to one chunk, compressed, and then written to long-term storage. So we have separate, very small index to look up from where the data is coming from and to find those chunks of compressed text. You might ask how can it be fast and how it can work without the huge index of all the data, how we can filter this text. So when we try to read something from Loki, it reads all the chunks that the time frame and labels match. So for example, if you want to read logs for just the log level error, it would match all the chunks that are described with this label, then span a lot of parallel reads and read everything at once. And then when everything is returned, it would only parse it then. So it works, this small index works like a like a table in a book at the beginning of the book, how it's called. Table of contents, yeah. So when you have a book, you have one page where you can find all the chapters in the book. So Loki would read, would see that, okay, chapter 3 is in a page from 50 to 60, and it would read all those 10 pages in parallel, return everything, and then process it. So I think this most important slide, and in the presentation. So this is the trade-off that design trade-off that Loki was built with. So with the previous now most popular infrastructures, we have a big fast index with very fixed high costs and complexity of operating. And with Loki, we have very small index, and we have to brute force querying of compressed log data. So with these popular infrastructures now, we have very huge high cost. We have Elastic Cluster, which works 24/7. It doesn't matter we use it or not. It's very difficult to scale it. Whoever managed the infrastructure like ELK or EFK knows what I'm talking about. You constantly have to fight the index if some log messages change, and but it's really fast and quite expensive, even if you're using beefy servers and SSD. And with Loki, we have low fixed operating costs, because all the data is compressed and stored in object storage. And we can scale Loki to increase its query power. So we change our query power on demand. So the price transfers from running index store to processing power. So if we are not processing anything in cloud native infrastructures, you don't actually have to pay for it. And when you want to query huge amounts of data, you can just scale your infrastructure a little bit and pay for what you query. Okay, so Loki components. We're going to see how scalability and high availability was implemented in this. This is, if you look at the bottom, I think this is just the same scheme, but in high level. There's logs, Promtail queries logs, sends it to Grafana Loki, and Grafana can query Loki for the logs. And we're going to dig deeper in Grafana Loki to see what it consists of. So Grafana Loki is a set of components that can be composed into fully featuring logging stack. And why am I talking about these microservices? Because Loki has two modes of operating. It can be a monolithic mode, so you can just run all services in one binary. It's very easy to launch and experiment on. And also a microservice mode, which describes itself. You launch every Loki component as a separate microservice, and you can scale it as your infrastructure grows. So we're going to look at all of these components to see what they do and what makes sense, what scale when. We're going to go in the direction of write path. So the first component is distributor. Distributor handles incoming streams, validates it, and splits writing into batches. We have ingester. Ingester just responsible for writing log to storage. And also stores a little bit of logs in memory. Then going through the read path, we have query frontend. It's an optional service. It's used for caching and additional splitting of heavy queries. So we would not destroy queryers. Queryers are actually used for querying the data from long-term storage from ingesters, and also for processing and filtering the logs. There's also a ruler on the left, but I'm not gonna expand on it. It's similar like in monitoring Thanos implementation. It integrates with Alert Manager, and you can set up some alerts similar fashion like in Prometheus. Okay, so with this very important factor with this picture is these purple lines. So Loki has a replication factor, which is free by default. What does it mean? So it means that every write is replicated by some amount. So by default, by free. So when distributor receives a write request, it actually tries to write the log, like sends the write request to 3 ingesters. So we have always 3 replicas of the log. So if one ingester goes down, we still have another 2. And if all of them go down, still distributor doesn't receive that log was written successfully and sends it again. So we can very easily scale, very easily restart and roll out changes without losing all the data, which is the main point which implements, like ensures high availability and easy scalability. Okay. How we implemented the deployed Loki Omniscient. So it's very similar like in the previous pictures. We have 4 Kubernetes clusters. On the left, there's 3 stacked one on another. We have Promptail log discovery tool, like which queries Kubernetes API, discovers the pods from which it should select query logs from, and then sends them to another Kubernetes cluster. We have this operations KAs cluster where all our tools that support remaining infrastructure lie on. And we have ingesters, multiple replicas of everything, actually. The scale, it's the same like in the picture before. Also, we deployed some Promptails on our VMs, and they're also sending logs into our Loki infrastructure. Additional to the picture that you see before, we have memcache for extra speed and querying, and everything is stored in GCP Google Store buckets. What is actually worth mentioning here is that Loki and Prometheus use the same solution for discovering targets. So Kubernetes API. So we end up with logs who have the same labels as metrics. So you can in Grafana view logs next to the metrics, and which easily helps us to debug issues. And I'm going to show it to you a little bit later in our demo. Okay, that's something. We have 500 gigabytes of logs per day. We have 5,000 log entries per second, and we have 10,000 different log streams. Quickly, we're going to review in the log query language, because in the demo I'm going to be showing you it in the logs, how Loki works. So Loki was built keeping in mind the developer and what developers usually want, or what Loki creators wanted, just to have a grep, and that's it. So previously, when there were no distributed systems, I think many developers had access to servers and could cat log files and grep what was required there. And now when everything is in a cloud or in Kubernetes, you can't actually, you're missing that command line experience. You can't watch logs from the pod that was destroyed a few hours ago. You can't access it through command line and grep it. And Loki creators miss this experience, and they build it with it in mind. So it looks similar like it. At top, you can just example of simple log query. At top, it's a label query. Just get all the logs which match label app full, and then pipes and different filtering and functions. So log query language improved quite a lot through the last year. It was released the version 2.0, and the orange things are the things that were in 1.0, and everything in white is new. So there are a lot of new parsers, more filtering capabilities. I haven't actually digged into formatting at all, and a lot of graphing support. I'm quickly gonna go through the challenges that we faced while deploying it, and then I'm gonna quickly show you our Grafana, how we view logs in it. So what first thing that we faced was performance tuning. There are a lot of labels, not labels, parameters that you can tune for all of these four services: distributor, ingest, and querier. And the first thing we faced was our chunks were too small. Like we had chunks just with few entries, with few log messages. So we had to tweak it because our applications were logging not that oftenly, and the chunk was just flashed empty to the long-term storage, and we were facing with very huge performance degradation. Also, we had to tweak a little bit of our internal load balancers, because when we wanted to query logs, for example, for a month, we couldn't do that. If you query such a long time, you expect it to take a minute or two, and our internal load balancers would just kill the request, which doesn't matter if the Loki was successful or not, but the load balancers were the problem there, so keep in mind. We're currently facing difficulties with educating the organization, because it's quite new tool and a little bit different than the conventional ones. And there's no custom retention for streams. For example, if you want to save logs for a longer time for a certain app, but have smaller retention for another ones, you can't currently do that. But as I looked, there's this feature is in Loki's backlog and currently being implemented. So key takeaways of the presentation: Loki was designed for incident investigation, not analytics. Loki creators say that they are not trying to replace Elk Stack, which has its use cases, but for incident investigation, I think Loki is the way to go. One front end for metrics and logs. It complements the incident investigation, because when you're looking at metrics, you want to see logs, and you don't need to go to another system to view them, which saves a lot of time and increases visibility. Also, same labels for metrics and logs helps for incidents a lot. And you can index some log fields, but it's not recommended. They say that Loki works faster with as smallest index possible. Well, if you think about it as a book analog, so you can find all the chapters in one page probably. But if you have a table of contents for every line, probably it would be even harder than to read the whole book. And small operating costs. So you pay for query power. If you don't need the query power, you just need to save the logs for a long time. It's the way to go. And demo. So I'm gonna quickly show you our Grafana, how it looks like, and try to view some logs. This, for example, I'm gonna try to go in a way of incident investigation. So I have this graph, which doesn't show anything here because we don't have anything interesting going on, but it's a memory usage graph for some pods. So if I want to see what logs this pod had at this time range, I would probably have to go to Kibana and then filter out some labels and try to select same range. But here you can just press explore, change data source to Loki, and it automatically pre-fills all the labels that are required. And if we query it, we should see some logs if there are any during past hour. when there's demo, there's always technical issues.
Maybe it doesn't have any logs at this point.
Yeah, well, the query is still spinning. Query error. Yeah, okay. So we have a few logs here. That's what I wanted to show, just logs in the same place as metrics. So you can have this actually as a panel below your metrics to even increase the visibility. Boom, boom, boom. Okay, what I want to show more, how we see some logs here. And these are the log labels which define the stream, which we configured it to have, but it also has some detected fields above. It means that Loki noticed that this log is written in some kind of format, so JSON or log FMT, and we can extract those fields on the fly. They're not indexed, but if you want to search, not the full text search, but for log level info, we can use formatter. We're gonna run the query again. Gonna see the same log, and now we see that log level appeared near labels that we can use for further drilling down or some investigation or anything else. So now I'm gonna filter just on level. We should not see info level anymore. This level. Yeah, see, now it just filtered out two alerts that match this query. And pretty much it. I'm gonna show you more advanced features of log query language. I haven't written these queries myself, so that's why I'm using prepared graph. This one's hidden, this one's okay. So we have a histogram of query duration. This is actually logs from Loki query. So it actually logs how long some query took, and we can draw a graph from that information. It shows how long all the Loki queries took, and shows in which pod there might be a problem, if it would be lagging or something like that. I'm gonna, I think, go a little bit back and check, show you how the log looks like. So we're gonna query all Loki distributed query pods and full text search for metrics go, because that's the library which is responsible for metrics in Loki. Probably selected too big of a catch. I'm gonna reduce the time range to simplify the query. So we can see the logs from which that graph that you saw previously was drawn from. So the log looks something like this, and it has duration field somewhere in its log FMT format. And from it was unwrapped and used Loki's graphing functions to make a graph out of it. Pretty much it. I'm sure I wanted to show you something more, but I can't remember now. So And I think my time is up, 30 minutes. So the last slide, our question slide.
I think we will move with questions just after second presentation, if you don't mind.
Okay, so thank you. And on the right, there's original log shippers in Nemunas 100 years ago.
Very interesting.
Thanks.
Thomas, do you need a break, or we can just proceed to second presentation? What do you think?
I think we can proceed. Let me just adjust some stuff. Screens. Yeah, we'll save some time for the questions. Right, let me just share my screen. Sharing the whole screen. So you should be able to see the slides, right?
Yeah, we see slides.
Okay, cool. So my presentation is about the Istio service mesh. This is going to be the intro level, the basic kind. We're not going to dig deep into all of the features of Istio and all the possible configuration options, because that's just too much. It's a complex system, and I just wanted to show the basics on how it works and how easy it is to configure, and how easy it is to start using it. So that's the agenda. What is Istio, when to use it, and the same importance when not to use it, how it works, and a simple demo. So in the demo, I'm not going to cover all the features. I'm going to be just one feature of Istio. That's just to save time. So what is Istio? It's an open source service mesh. So what is a service mesh? Well, I actually Googled it. What is a service mesh? And it's just a simple service-to-service communication layer. That's about it. It's not some magical thing. It's some fairy dust on top of it. Just a service layer, that basically network layer between your services to allow communication between them. Yeah, as I said before, layers transparently into the existing distributed applications. Now, keep in mind that all of this is for in the context of Kubernetes clusters. We have some Kubernetes, we have some services deployed to the Kubernetes cluster, and there's communication between them. If it's not monolith, it's not a monolith. Let's say you have 5 microservices and there's dependency of one another, and there's obviously a network traffic between them. So that's where Istio comes in. It can shape route traffic and basically transport the bytes between one service and the other service without any code changes for your services. It uses Envoy, so it's not something proprietary to Istio. It uses Envoy proxies as a sidecar in the pod. It's not an unusual pattern. Lots of other operators use the sidecar pattern to add features to the Kubernetes cluster, which is not provided by the Kubernetes by default. But it's interesting on how it's done by Istio and how it works, because if you know sidecars, it's just a container you can launch in the same pod alongside your main service. And for some time, it was interesting for me in how it was actually how Istio actually intercepts all of the traffic. But that's how it does. It intercepts all of the traffic for your services. So we'll cover that later. Obviously, Istio is implemented using the operator pattern in Kubernetes, so it's using CRDs custom resource definitions. It adds a lot of different CRDs for an end user to configure or a Kubernetes cluster operator to configure. And all of the configuration options are in the CRDs or CRs. So there's no need to go into the cluster and tweak something. It's all controlled through the YAMLs and custom resources. Yeah, last 2 bullet points, just security connects your application. One of the best features of Istio is MTLS, which is effortless. It just works. You don't need to configure any certificates or anything. You can add MTLS between your applications just like that. And yeah, it extends standard Kubernetes network management granularity by adding multiple features. All of the features that Istio adds is on the application level, so it's L7. While Kubernetes also has network policies, which stays at L3, L4, I think. Both of them work together, so there's no need to choose between one or the other. It should work in combination, basically. The difference between those are the Istio service policy, network policies are applied on the pod, while the Kubernetes network policies are applied on the actual worker node of Kubernetes cluster. And all of this is achieved without any code changes in your services, which is excellent. So what it looks without Istio, this is the service-to-service communication in the Kubernetes cluster. So service A wants to send something or query service B or service B API that exposes, it just works like that. And with Istio, there's a bit more complexity going on. So as you can see, here we have envoy proxies, which are actually sidecars using sidecar pattern. This is just another container in your pod. So these two are pods. The whole Istio control plane is also running inside of Kubernetes, or it could be externally ran. Usually it's running in the same cluster in the Istio system namespace. So yeah, it's just a set of pods. Before, don't remember which version they switched. So currently, there's an Istio-D, which has 3 components. Before that, it was ran separately, but it's simplified now. So when to use Istio? Obviously, one of the features. When you think about Istio or under service mesh, you want the features that it brings, and that's why you want to use it. So Istio features, traffic management. So I'll split this into 3 areas: it's traffic management, observability, and security. So for traffic management, first, obviously we have routing, ingress, both ingress and egress traffic could be routed on the cluster level and on the pod level too. We also have circuit breakers. For those who don't know what circuit breakers are, it's a mechanism to stop the traffic coming into your application based on something or some attributes that you define in advance. For example, if service responds 50 times with 503, you just cut the traffic to it, or kill the pod, replace it with a new one. So that's basic circuit breaker. Or if you have, for example, different versions of your application running inside the cluster, you launch a new version 2, and you see that the version 2, you can configure it to, in case the version 2 rejects all the requests, you switch back automatically to version 1. Timeouts and retries, that's just self-explanatory. So any request, well, I guess if I explain it in comparison with standard Kubernetes and how it works, the traffic routing and management and Istio. So without Istio, if you send a request and it goes to the application and times out, you have the timeout. You have whatever the code is returned from the English controller or directly from your service if you don't use English controller. With Istio, you can configure timeouts and retries before you see something coming back from your application. So you can configure, for example, if the request is retried 5 times and it doesn't succeed, so the envoy proxy automatically returns the 503 error, which means service unavailable. Same with the timeout. You can configure the timeout on how long the request should wait before it should be timed out. And Istio would respond with basic or pre-configured timeout message. Sorry for that. So canary deployments. So when you want to switch some part of the traffic to another version of your application and not all of it, you can launch a canary deployment and control the percentage split for the traffic, which is also used for A/B testing. Right, next to observability. So obviously metrics, which is collected and exported by Istio to Prometheus by default. So if you have Prometheus scraping your cluster, all of the metrics, and if you have this discovery enabled in Prometheus, so all of the service mesh metrics are automatically scraped. You have a lot of data there. The requests, the latency, the count of requests, the count of bytes transferred between the services, just very extensive. So, and all of this you have out of the box without configuring anything. It's distributed traces through envoy proxies. Obviously, that's not, envoy cannot look into your application and what's happening between the layers of your application inside of it. It just can observe the traffic going in and out of your application and between different applications, since it's all proxy through the envoy proxies, and provide your distributed traces between the applications and basically an overview on the traffic in your service mesh. If you want to, you can extend these distributed traces by just transferring the span IDs in your code when you do calls to different controllers or different points inside of your application, and just to add to the distributed traces that are automatically generated. Access logs. I know it's available, but I think it's kind of a pain to enable because it's enabled at the envoy level. I personally never done that. I know it's possible. When you enable the debug logs in envoy, it's just so much information that it just clogs it. Sorry about that. It's my dog just came into the room and just chewing on something. Right. Security, peer authentication, MTLS. I think that's the most valuable feature of Istio, which is effortless MTLS. And it's transparent too, so your application doesn't even know that all of the traffic incoming, outgoing, and the traffic between your distributed services inside the Kubernetes cluster is all encrypted. It looks, from the application standpoint, it looks like it's normal HTTP traffic. So Istio comes with different modes of MTLS. By default, it's could be, I think it's disabled. So it could be also permissive, meaning that the applications or the namespaces that, since peer authentication is enabled on the namespace level, so the namespaces that enable MTLS could communicate with the services deployed in the other namespaces, which did not enable MTLS. That's the permissive mode, and strict mode is MTLS or nothing, or request doesn't doesn't go through. Request authentication. That's an interesting and very powerful feature. So Istio is able to inspect JSON Web Tokens or JWTs if your requests have it. I think most of the modern services use JWTs for authentication and authorization. Not even that. So Istio is not only is able to access this information, but it can also verify the signature of JWT by inspecting it and seeing what's the issuer. So it integrates automatically with Okta, Auth0, and there's a bunch of other authentication providers which Istio integrates with. So if you can basically drop. Well, you shouldn't drop the authentication in your application code, but you could if you want to, and transfer this this duty to Istio Service Mesh, because it can inspect it, and if the JWT is expired, it will automatically reply or send the request back to the request response to the calling user, saying, hey, your token is expired, and this request doesn't even reach your application, so it can filter all of these. So it's also when you have JWT, it's able to extract the audience and most especially the claims, which you could use in authorization policy. So you can define with the custom resource who can access what. So, for example, we have a claim that says, I'm an admin. So with this information, or a simple user, right? So with this information, you can configure in advance what could be accessed by admin and what could be accessed by user. For example, your application has sorry for my handwriting, it's barely readable. Health endpoint, which should be accessed by Kubernetes API and probably could be accessed by anyone, since it doesn't need authorization or authentication to get the information. You can configure that in authorization policy to be freely accessed by anyone. And if we have something like /API v1, probably don't want this to be accessed by anyone, just about anyone. So you can use the claims in here to configure authorization policy to only allow certain claims to access certain paths in your or endpoints in your service. It's very flexible and quite powerful feature. You also have egress control by service entries. By default, it's not enforced. So when first install Istio, it's not enforced. So all outgoing traffic is just outgoing, but you can enforce it, and all of the outgoing traffic from the services will be locked by default. It will be denied unless you define service entries to allow it. Now, the real cost of Istio. It's all good and it works, and you install it and use all the features, everything's magic, and it adds a lot of value for your services and for your product. But let's think about the real cost of it. So first, it's steep learning curve. All of this that I just talked, it's just the basics of what it offers, the basic functionality, which could be extended way further than that. And that comes with the cost of learning stuff. So it's not an easy, when compared to something like Blinkerd version 2, it's much more complex system. Yeah, as I just said, the configurations often is just too complex. You can start small, you could do that, but then when you add more features, it just starts piling on top of what you already have. And for that, you need either a dedicated support team or dedicated person to kind of keep an eye on it, especially on the maintenance side, because in the Kubernetes world, things changes very often. I think Kubernetes alone releases 4 major versions a year. So every quarter, there's a new version. Current is, I think it's 124. So it takes effort to just keep it up because it drops the long-term support after some time. And all of the cloud providers that offers Kubernetes as managed service also drop the support. So you're left on your own to patch things if you don't update the versions. When it comes to updating version of Istio, and also you need to update the version of Istio because it's not compatible with the certain versions are only compatible with certain versions of Kubernetes. So it's not like you drop Istio 1.10 into Kubernetes 1.18 and hope it to work. It'll probably not work. And that's the thing with Istio upgrades for Istio. So when you install Istio and route all the traffic to Istio, it deploys its own ingress controllers, meaning that the cloud provider it will create load balancers which are backed by Istio ingress control. So all the traffic goes through Istio. And what it means, when you want to upgrade an Istio version, it could possibly mean downtime for your application unless you do like it was done, I think once in the project that worked before. A colleague of mine did the update, and the plan was to start a new Istio service mesh with the new version alongside the old one. It's possible, and I think at that time for that version upgrade was a recommended approach. So basically, we have 2 service meshes running alongside. All of our services were deployed into the old one before we could move to the new one. So we deployed the new service mesh in the new version, new Istio. It meant that for some time we ran double the load balancers because it deployed its own ingress controllers, which means obviously a load balancer. And you switch the gateways, which I'll talk about it later, one by one, basically to just migrate from one service mesh to the other. And once that's done, you can drop the old service mesh. All of that requires knowledge and requires dedicated support person or team. So if you don't have it and you think, yeah, let's just drop Istio into our Kubernetes cluster and be done with it, that's not how it will work, and it will going to bite you at the next major version change. Last but not least, you need something or someone in your organization to support application teams adopting this too, because one thing from my experience, the Kubernetes itself, often it's too complicated for the application teams. They want to just write their product and ship it, whatever it means, just ship it to production. So if we add Istio into the mix on top of the Kubernetes, which is also a complex system for most people, you need some advocates of Istio and the features that it brings. Once these teams migrate to Istio, you need to help them implement the features that they need with the help of Istio. So you need someone to kind of advocate and keep an eye on the configuration that you're putting into your service mesh. Right, when not to use Istio. This will be basically an inversion of what I just said in the section just before. There's no one to maintain after installing it. So if someone installs it and leaves the company, no one takes its place, then that's a death sentence for your product after the next major version change for Kubernetes and for both Kubernetes and Istio. So if there's no one, just I would say don't even start with Istio, especially in production, because it will break. No one is there to help to adopt Istio for application teams. It's self-explanatory. Sometimes working with Istio is a full-time job, especially during the migration of versions. Sometimes it takes weeks if you have multiple, like 100 workloads on your Kubernetes cluster already migrated to Istio. And especially if you need to migrate to different major versions without any downtime, that's a full-time job for some time. And last but not least, random 5 XX errors. Sometimes it's just like you get a P1, the application is down, you get 5 XX errors, and you don't even know where to begin. Because in production, the Envoy debug logs are disabled because of the enormous data they produce. And after spending 5 hours debugging, you see that it's just works as it's supposed to because you messed up with the Istio configuration of the CRs. And that happened for me and for my team a couple of times at least in the past, and it just worked as configured. So that just shows the complexity of it. So how does it work? Just like that, it's magic. Now, but for real, it's not magic, and it's you'll dig deeper into the network layer and how it intercepts network. Right, installing is just one line. So there's Istio-ctl, binary for controlling and inspecting service mesh. And Istio, you just install command, you can drop Istio into any Kubernetes cluster that you have. Before that, you need to see what kind of versions are compatible and download the appropriate version based on the Kubernetes cluster version that you have. Yeah, there's different profiles. Obviously, you don't want to install it like this in production. It supports different install modes. The one that you want to use in production is called a manifest. So you can prepare all the configuration YAMLs. And just use that, and don't use the interactive install, obviously. You can use Helm or Helm chart to install Istio service mesh. It's also a viable installation option. Now, for Istio to work, you need to enable the sidecar injection, because only then Istio could inject your pods with the Envoy proxy and just intercept all the traffic in your services. So for that, you need to add a label, a simple label, Istio injection enabled or disabled. You can also add different labels of, especially if you have different versions of Istio running in the same cluster. Not saying that the recommended approach, but that sometimes that's an approach when you want to upgrade. You can specify which version is allowed, which Istio version is allowed to inject Envoy proxies into which namespaces. So how it would look like? Here's my mouse. I'm sorry. That's how it would look like. A similar picture to the one that I showed you before. So all of the traffic is intercepted here by Envoy. Your application doesn't even notice. It thinks like, so your application thinks like the traffic goes like this, but actually it's intercepted by the Envoy proxy, and that's how it's able to enforce MTLS, because MTLS is only enforced between the proxies, since no other traffic leaves or enters the pod, avoiding the proxy. So your application could listen on port 80, but all the incoming and outgoing traffic will be encrypted. Now, this scary diagram I took from the chimisong.io. This dude went to all the trouble explaining this stuff and drawing this diagram on how Istio is able to intercept the traffic. So check it out if you want. So it's really easy. I'm just going to quickly go through it and just mark some stuff as I go. when you start, so when the pod starts with your service, Istio acts as an operator and injects two containers. So one is int container, which contains a script to set up the IP tables for your pod, since pod shares the network, and the communication happens between the containers using ports. That's how it's able to intercept all the traffic by simply altering the default IP tables configuration and the route all the traffic. I'm not going to go through all the steps that it does. That's just too much. It's able to do that by routing all the incoming traffic to port 15.0.6 and outgoing traffic to port 15.0.0.1. And this is the sidecar proxy here. After it applies all of the configuration that you expressed in YAMLs, and by Istio translates it into the configuration that my proxy understands, because that's a different kind of configuration DSL. So it communicates with your, then my proxy communicates with your service by proxying out all of its traffic. That's how it's able to control it and basically enforce the traffic configuration that you have in your cluster. Right, so that scary part is over. As I said, I'm not going to cover all of the steps. If you want, you can go check this website out to see the details. So now what it means in terms of the Kubernetes objects. Normally, you would have this without Istio, just an ingress, given that you have an ingress controller. When you create an ingress object, you'll have, or you basically tell Kubernetes how to route your traffic to one or multiple, or the other service you have deployed inside of the Kubernetes cluster. With Istio, that translates to two objects which you must have in order to flow the traffic to your service. One is the gateway, and the other one is virtual service. So we basically split the vanilla ingress Kubernetes object to two. And by doing that, you gain a lot of flexibility in terms of configuration, retry, circuit breakers, traffic routing to different versions by splitting the traffic in percentage to your services. All of that is achieved just through splitting the ingress into gateway and virtual service and all of the other Kubernetes resources, Istio resources that it adds to your cluster. So for basic usage and for the demo, we're going to cover just three CRDs. It's a gateway, and the gateway is basically saying, hey, I have this host, and the ingress controller that is still deployed should flow the traffic if it matches this host to this gateway. Then the virtual service is kind of binding to that gateway, saying that, hey, I have this host which should accept traffic from this gateway and route the traffic to this service. And the service is the Kubernetes service that you have. And it's a good practice to have at least one destination rule. Virtual service could work without any destination rules, that just forwarding 100% of the traffic to your Kubernetes service, but it's usually beneficial to have at least one destination rule, which also routes 100% of the traffic to your service, but then it adds an ability to quickly split the traffic when you need. So done with the slides. Now let's get the interesting part of the demo. So I took the example application, which is book info. All of the docs and how to use it is on the Istio website. Didn't do any custom modifications to it. That's an overview of the product. So it's a polyglot application. So it uses Python, Java, Ruby, and Node.js, just to show that there's no code changes needed when you want to flow the traffic or shape the traffic to different versions of your services, and then Istio doesn't care what your application is as long as it's a container. So this is the application without Istio, and this is application with Istio, which acts exactly the same as the application without Istio, but then I'll demonstrate how we could easily extend or easily change the way the traffic flows to one or the other service by just simply changing the CRs of Istio. So what we have here, we have all of these boxes are envoy, and there's no destination rules, which is basically saying that all the traffic goes randomly to, well, it's round robin actually, to all of these preview services. If you look closely, we have 3 versions, so version 1, version 2, and version 3. It's an unlikely scenario to happen in production because you don't normally run 3 different versions of your service and just routing traffic through all of them at once. But just for the sake of the demo, that's the case. And we have our ratings microservice, which is used by 2 versions of preview service. So version 2 and version 3 uses the rating service, where the version 1 doesn't use the rating service. That might look confusing, but I'll just quickly show you how it looks like actually on the web page. So hopefully you see the web page, right? You can see the Chrome.
Yes, we see Chrome.
Okay, thanks. So that's the product. So this whole thing is the product. Book details is one microservice. Book reviews is another microservice, and these little stars is the third microservice. So if I click refresh, you can see that sometimes the stars are red, sometimes it's black, and sometimes there's no stars at all. That's the version 1 of the preview service, which doesn't go to the rating service to get the stars and doesn't show anything. This is the version that goes to the ratings and just applies some styling on it, the black stars. And then that's the third version, version 3, which is, I think it's orange or red, red stars. So we have 3 versions working simultaneously. So whenever we refresh, we hit the other version. Now, how it looks like inside of the service mesh, I'm just going to share what I'm going to do in the terminal so you can see. Hopefully it's readable. Expand it a bit.
It's fine.
Cool. Right. So what we have now is I spin up a new cluster for a demo. VS is virtual service. So we have one virtual service, book info, and just nothing else. The beauty of Istio is you can, at any time, you can add multiple virtual services, and just by specifying host the same as your Kubernetes service, you can shape its traffic without changing anything, just by defining multiple virtual services. We don't have destination rules. What else? We have just one gateway, book info gateway. So now we can launch. So with Istio, we have add-ons which are already installed into the cluster. One of which is Kiali, which will help us to visualize the traffic inside the cluster. So have it deployed. What it does, it just proxies the traffic. And we see nothing for now, but I have a command here which generates some traffic. So all of this is they'll be drawn dynamically from based on the metrics that Istio exports automatically, and could be ingested into Prometheus. So give it a couple of refreshes to fully draw the mesh. Yeah, now you can see there's Ingress Gateway. That's where the traffic comes from. It goes to the product page, which is this, the entry point of our product, the entry service. It's V1. It also it's able to detect the version from the annotations that we put, from the labels that we put onto our pods. So you have version 1 of product page, version 1 of details, and 3 versions of previews, and one version of ratings, and which we could see version 2 and version 3 goes to ratings. All of this is live. So if I cut the traffic, we stop seeing this. There's a ton of things to choose here to add some stuff onto the lines that it draws. So it's able to show us how much requests are we getting, requests per second. It's 2. I want to pause. Right, so now, as you can see, the traffic comes from product page when it tries to reach service, and when it tries to reach PV service, which has 3 versions. This happens simply by, if you go, I'll just open another tab. We go to service, and it's review. There's a selector, app reviews. So we have 3 pods, 3 review pods, and reviews. And it has the same label, but it also has, remember the label for the version. It's V1, V2, and V3. So without changing any code, just by changing the Istio configuration, we are able to shift the traffic in real time. Now, hopefully this works as I expect. First, we need to configure the destination rules. So for that, I'm going to download. Yeah. So what I'm doing here is I'm creating a destination rule, one for application. Now we have one destination rule, which basically saying, let's take this for example. So it adds subsets where we can use subsets in our virtual service to control the traffic flow. So this just creates a destination rule for every subset that we have, and it changes nothing, as we can see in live traffic. Now, let's say you want to split, or not split, but we want to say to our service mesh that we want to route all of the traffic to only version 1 of all of the applications. So let's do that by applying this. Let's see what it does to the reviews service. Virtual service. Now, compared to before, we have 4 virtual services. Let's see what we changed in this one. And it just says route, destination, host, and this is the important part, subset 1, V1. So we want all of the traffic routed to version 1. Let's give it a couple of some time to change it. There should be an option, traffic rate. Yeah, you can see most of the traffic is now coming to version 1. And the rate drops for the other ones, so it's 0.9, and after the refresh, it's gone. So all the traffic goes to service version 1, and this is without any code changes, just with configuration. Now let's say we launch service 3. Doesn't matter if you already have it, just for the sake of the demo. If you launch service 3 and we want to do some A/B testing on users. So we switch 50% of the users to version 3 and the other 50 to version 1. So we do this by just changing the virtual services. So now when you check the review of virtual service, you see we have 2 destinations now. So one is subset V1 and the other is subset V3, sorry. And the weight is 50-50, so it's percentage. We can say weight is 1 for V1 and we redirect 1% of the traffic to version 1 and 99 for version 2, but in this case we have 50-50. And you already see that that's what it did. It distributed the traffic to version 1 and version 3. If we follow the traffic long enough, this would even out. Now it's still needs some time, but don't have time for, yeah, now it's even. Right, now let's say we're happy with version 3 and how it performs, and you can see now that the version 1, remember, has no stars, and version 3 has red stars. So by refreshing the page, we have no stars or red stars. So no downtime for the application at all. Now we say that, yeah, we're happy with version 3, we want to switch to version 3. And it's easy, just switch 100% of the traffic to version 3, or just simply remove the subset. Yeah, now it's just one destination. It's worth mentioning that Istio is eventual consistency type of system, which means that the changes are not immediately applied to all of the pods. It's eventually consistent, so it will take a second or 2 to apply the changes. Now, however times we refresh, it's version 3 always. And here you'll see, should be able to see that traffic is no longer going to version 1, so it's 0.4 compared to 0.16. I think I need to load more traffic. Yeah, generator stopped. Let's do this. Now to be sleep. Yeah, all the traffic goes to the version 3 now. And this is just the basics of basic splits based on the percentage. We can do much more with this. We can switch traffic based on the values in the HTTP headers. We can switch traffic based on the JWT claims, and whatever you can think of, it's possible. And some of the advanced scenarios are covered in the Istio website, so you can play with the same demo with SIP setup that I just displayed. And there's prepared samples on for you to try out. So if you want to try out Istio, just I would say start with the booking info app, because it really showcases the Istio capabilities, and it's a good starting point for you. And that's the end of my demo and then my presentation. So thanks, and yeah, I'll transfer the management to Slant.
Thanks, Thomas. That was really interesting. Probably we need to move to Q&A, and I recommend to return to Loki presentation and just go through the list, because I see there are a lot of questions for this topic. Maybe I will just read, so it would be on the recording. Augustinas, are you ready?
Yep.
So there was question, what are the savings when ingesting 1 terabyte of data a month when compared to ELK?
I don't have actual costs for running ELK, because I never measured it. actually, but what it says in the internet that for 100 gigabytes per day, to run Elk in the standard AWS, it costs around 15,000 euros, or I don't know, monies per month. And currently we with Loki have 500 gigabytes per day, and we pay around 2,000 euros per month for everything, like including storage and approximate, I don't know how to say, calculating the cost for Kubernetes pods, because we're running Loki in Kubernetes, so we can't actually say how much we pay for those pods, but according to our cost service, it's around 2,000 euros. So for 5 times more logs, we pay 10 times, like 5 times less.
Okay.
Good savings.
And there is also a question, does the prompt tail run as a daemon set or acts as a logging driver like Greylog for EVS firelines?
Yes, prompt tail runs as a daemon set. It's similar to Fluent Bit or bytes, log/bytes, or how they're called, I think.
So it's just to expand on the question, because that's mine. So the way the other log, the Fluent Bit works, I think, it just scrapes or tails the output of the not the output, but basically when you run the Docker, it forms a JSON file which Fluent Bit tails, and then it ships that. So I'm wondering how the prompt tail works. Is it the same manner? Because when you run the daemon set, you have access to the worker node, the file system. You can tail the file.
It also tails the file, checks Kubernetes API for pods that you want to actually collect the logs from. You can configure that. You can accept some namespaces or ignore some pods, and it just catches the file and tails it. Yep.
Okay, thanks.
Okay, next question.
Does it support structured logs like JSON? I think I showed in presentation that new log query language has this support. And also wanted to show you a little bit more. Can you see my screen?
Yeah, we see your screen.
Yeah, so the same way as it showed with log FMT, we can do the same with JSON. Yeah, right here we have a JSON log in the log message, and after applying -JSON, you can extract all the fields and use them for all different kind of things. And I would share my screen for one thing. We have this magic trace button. Actually, this service uses a logging library which includes this tracing ID. And what Grafana does, we can just click this and get all the tracing information for Golang application that we're running. Ta-da!
Is it a tempo used for tracing, right? Is it Grafana tempo? Which data
not.
source?
Yes, Grafana tempo.
Oh, yeah. Tempo, yeah, okay, sorry.
Okay, I think this is a good answer to that question. Does it support structured logs?
Right? Yeah, it does.
I also have a question. Does Loki support multi-tenancy? And is it possible to isolate different logs within Grafana? For example, within Grafana organizations?
I Googled it, so it's possible. I haven't tried it, but there's a tab in like the documentation for it. No further comments.
Okay, it's fine, probably. Another question, is there a feature where you can request a log to be queried and check it out later? This would help battle the load balancer timeouts.
As I know, not, but Loki is very good at caching queries. Okay, I won't share my screen anymore. But if you, for example, query logs for 1 hour and then increase the time range, it won't query the first hour again. It just keeps it in the cache and then queries another hour. So to make Loki faster, it's probably sometimes easier to just increase the time range that you're querying, not just query instantly 24 hours, but query 1 hour, 2 hours, 5, and then 6. So you can work with the data while the query is running in the background.
Okay. One of the next questions, is it worth to choose Loki if clients would like to send a lot of raw logs and don't want to refine message structures?
No, it's my personal opinion, but yes, because Loki doesn't care about the log structure. As I showed, if the log has some structure, you can use some parsers and then have some extra features. But Loki will write those logs to long-term storage. It doesn't matter what kind of format they are, and you can always use full text search, which works quite okay.
Maybe one additional question also from me. When you use full text search, how it's compared to ELK? Is it much more slower?
I haven't did any benchmarking, and depends on probably streams that you're running the search on. Because if you're running full text search, Loki has to query all the data that he's filtering it on. Like, doesn't matter if only the 10% of the logs have this field that you're searching for, it's still gonna query everything. So probably full text search, I don't know. Well, can't say. We need to benchmark it.
Yeah, okay. Because I heard that Loki seems is much slower when you do full text search of any field, which is in raw logs or something like that.
It might be related with those challenges when deploying Loki that I mentioned for performance tweaking, because there's a lot of flags that you can configure for chunks, and the amount of chunks and amount of labels that you have in Loki, like streams and labels. Yes, labels with defined streams really impact the query performance. At first, we missed a few configuration options, and we are ingesting logs and labeling wrong fields. We had very, very big cardinality, and our queries were also really slow. But now we increased it, and I think we can query month range logs really fast, like up to a minute.
Cool. Sounds really cool. So as far as I see, I don't see any questions for Augustinas. Does anyone else has any questions? So let's move on to second presentation.
Just add, you can still ask questions after we ran up all of the questions in the chat, so you can just ask. Right, so first question is, how do you solve Istio monitoring issues when running lots of pods in the cluster? I'm not sure I get the question. What's there to solve? Did the monitoring Istio itself or monitoring of pods?
I think Augustinas clarified the question I was asking for, so you can proceed to the next one.
Oh, how do you handle metrics from Istio? Well, that's a monitoring task, right? If you run Prometheus, a clustered Prometheus, or if you have more money and you use Datadog, for example, that's another problem. Actually, that's a current setup from one of my projects that I'm working on. But the customer has Datadog, and there's no problem from handling all of the metrics from Istio, because it just ships the Datadog. That's it. When running Prometheus, that might be a challenge if you run it on your own. You might probably want to look into a long-term storage solution like Kaunas or M3 or any other long-term storage solutions, because that's a lot of metrics and a lot of unnecessary metrics, and it's probably just noise. So I would not recommend to ingesting all of them into the Prometheus if you run it yourself, just the ones that you want, because you could just not ingest the ones that you don't want, and the ones that doesn't bring any value to you.
Okay.
Right. Hopefully that answers it.
Okay. Next question, as far as I see, was about maintenance of Istio itself. I think it's partially answered, and it's it's sad. It is sad.
Yeah. So for maintenance, you would really want to have a dedicated go-to person or go-to team. Usually it's the platform engineering teams that run the service meshes. Downgrades don't usually downgrade Istio, because when you want to upgrade it to a major version, it's probably tested already and it's pretty stable, so you just upgrade. Now on the compatibility, there are components which are not compatible with Istio. From my experience, we have one, which I'm not sure if it's alive right now. It's called Flagger. So it was used for canary deployments. It's another operator, and it just didn't work with Istio at all. It used, there was a feature of it which could load test the new version of the service that you want to launch before switching all the traffic to it. And that didn't work with Istio. It just broke. So later we just removed the Flagger altogether. But yeah, there are issues with some of the components that you want to deploy in Kubernetes, which not necessarily work with MTLS, and which might want to do something that Istio does not necessarily allow you to. So yeah.
Maybe I will elaborate a bit the question. Actually, I have in mind that when you upgrade Istio, is it expected that some components might break after upgrade, like wouldn't support some functionality which was working before also new version?
No, it's once you have Istio, if nothing breaks, it will not break during the upgrades, because that's what it does. It just proxies the traffic, and if something gets in the way of proxying the traffic, it's going to be a problem. But once you launch it, I don't think it will be any problems by upgrading it.
Okay. There is also another question: any downtime for applications when upgrading Istio?
I want to
No.
clarify this, like a little bit add to the question, because you answered it during the presentation, right after I asked it. Actually, the question is where the downtime comes from, because you said there is some, and I was very surprised because when services run with Envoy sidecar, you just restart the service, it spins up with a new Envoy, and there shouldn't be any downtime there.
Yeah, so what I meant is there's going to be downtime if you don't have a dedicated person upgrading the Istio. So once you decide, or someone decides, hey, let's upgrade the Istio, drop in, and it will, for some major versions, you have to delete all of the CRDs for Istio because it changes version, so it's incompatible with the new version. And by doing that, you're effectively bringing down all your ingress controllers. So with the
but those CRDs actually, is it for Istio or is it for something else?
Istio CRD. So this custom resource definition is just for the specific controllers in this case, or operators. In this case, it's Istio. So Sometimes it's when you upgrade to a major version, it's incompatible. So you have to delete, or as I said, you have to launch a new version of Istio Service Mesh, just transfer your applications to that one. Right, so it's you want to put this task into your hands to someone that knows what it's doing.
You need dedicated resources to take care. Yeah.
Yeah, I think so. That's a good approach.
Okay. And last question, I think, is there a way to overcome the issues with misconfigurations? How to avoid those 500 errors?
So on the misconfiguration, I closed it. So the tool, the visualization tool that I showed Kiali, it shows you the issues with Istio configuration. So there's an option in the menu. Well, I closed it, but there you can. I'll quickly launch it again to share my screen. So it's possible to detect it. Here, Istio config, and says configuration is fine. So it has all of the configuration for your services. So if I would remove a destination rule, for example, all the destination rules for the virtual services, it would show this. There's something wrong with the booking for virtual service because it lacks destination rule. Yeah, that's one way. Another way is this thing. It says Istio component status, Istio egress gateway not found. So I didn't deploy an egress gateway, and that was picked up by the Kiali. So normally you would want to shape or control your outgoing traffic in the cluster. And in this case, you would deploy the egress gateway. So that's another way to detect something's misconfigured. Now on the 503s, I don't think there's a way to avoid it, and it's not as big problem as I told during the presentation. It's only a big problem when you encounter it, right? So for most of the time, it's fine, but sometimes you just hit random 503s for no reason, it seems.
But is it so random that you get one, or you get like, I don't know, 30% of requests are failing at that time?
No, you just get, sometimes it's on pattern. So we have 0.005% failing requests only for certain hours, or only for certain requests. So these kind of annoying things. So 99.9% of the traffic is fine. It's just for, these are little annoyances. If you run a big workload, if the workload is small, like if you don't have much traffic going in or through the service mesh, that's not going to be a problem unless you seriously misconfigure something. So I would look into this from an angle if when you're using something extensively and you're using multiple features of the product, it eventually run into something that doesn't work since it's open source, right? You have a support, dedicated support, which could help solve your problems. It's open source. It comes with its own risks, but I think everything does. Like if you don't drive a car, it doesn't break. If you start driving a car extensively, there are these little issues that comes up. There's little rattle noises here and there. So I think that's the same case with Istio. So if you use it, you'll notice these things, and that's just part of it.
Okay. So I think our list of questions is over. Not really sure. Maybe someone else has any questions.
Yeah, you can just speak up or write into the chat.
If you have any questions after this meetup, you still can ask. Find the speakers. I think every one of us would be happy to answer if there would be any.
Yeah, you can reach us out.
I think, Thomas, we are going to wrap up because
Yeah, I think that's we'll come to an end of the first online meetup. And we would like to thank you all for participating, for joining. Thanks goes to Augustinas. Big thanks for being one of the speakers. I think Loki, the really interesting technology and alternative to standard stacks. Yeah, thanks for joining, and we'll see you next time. In the couple
Maybe,
of months, hopefully.
yeah, maybe one thing, we're always searching for speakers, for new speakers, because Thomas was speaking already like several times, and it's of course interesting to speak on your own meetup, but we would like, to see someone new faces, also new experience, someone who could share their experience. We do not require like advanced topics. We also ready, to show people one-on-one topics or something else. So please be more proactive and write us if you have anything to share.
Yeah, it doesn't necessarily need to be direct Kubernetes use cases. It could be technology surrounding Kubernetes, like the log aggregation that we just saw today, or any other technologies remotely related to Kubernetes. That's fine. It's still interesting.
Yeah.
Right.
So.
Okay. Yeah. So I guess that's a wrap up. Thanks for joining, and we'll see you next time.